Today topic is resonance. This resonance is mainly classified into two parts, that is series RLC resonance and parallel RLC resonance. Okay, this resonance will be mainly occur in RLC circuit. Now coming to the resonance important topics, the points on resonance. These resonance may be occur due to the effect of inductor and capacitors. Okay, because of mainly inductor and capacitor, the resonance will be occur. For example, if you are taking RLC circuit, in the circuit both inductor capacitor are exchange energies freely as a function of time. Simply the resonance will be occur. Okay, we have another definition. If the both inductor and capacitor energies are balanced as a function of time, simply that is also resonance. Now what is the condition for resonance? XL equal to XC. If you are taking XL equal to XC in the impedance, simply that type of condition is called as resonance condition. Now the frequency at which the voltage and current are in phase. Sir, before going to the frequency at which voltage and current in phase, I am discussing with at resonance the circuit behaves like a pure resistor. If you are taking one impedance formula, it is a combination of real parts and imaginary part. When the resonance will be occur, simply the imaginary part is 0. Simply I am taking Z equal to R. If Z equal to R, the total circuit behave like a pure resistor. If imaginary part is 0 at resonance condition. If the circuit behave like say pure resistor, simply that type of circuit phase angle is nothing but in phase. The voltage current angle is in phase in our resonant circuit. Now these type of resonance are mainly application for communication system as well as filter design. Now I am taking series resonance circuit. It is a combination of RLC with the AC supply voltage. This is the instantaneous voltage of the total circuit. If the imaginary part is 0, simply I am taking resonant condition. The condition is XL equal to XC. If the condition is both are equal 0, the XL value equal to XC, simply I am getting omega L equal to 1 by omega C from XL and XC formulas. From XL and XC formulas, I am getting omega L equal to 1 by omega C. Now after completion of that one, omega square equal to 1 by LC, then omega R equal to, what is omega R? It is a angular resonance frequency equal to 1 by root LC. The units of this total omega are nothing but radian per second. If you are substituting omega R equal to 1 by 2 pi fr, at resonance I am taking omega R RFR. Okay, but normal condition I am taking omega and F, but at resonance condition I am taking omega R as well as FR. If you are substituting omega R equal to 2 pi F into R, simply I am getting FR equal to 1 by 2 pi into root LC. The units of resonance frequency is called hertz. Okay. Now at resonance, what is the condition? Simply the imaginary part is 0. If you are taking the imaginary part is 0 in an impedance, I am getting Z equal to R. This is a minimum value compared to this total equation. This is a minimum value. If you are taking the Z impedance is minimum, simply our system response, that is equal to I equal to, from the I equal to V by Z, the current, the response of the current is maximum. Simply I am observing some points from this explanation. In this series resonance offers minimum impedance because of this reason, and I am getting some maximum response from the RLC series resonance. If the minimum impedance is there, simply the response of the circuit is also maximum. Simply I am getting maximum current. This type of circuit is called as acceptor circuit. Now what is the power factor of this circuit? That is a unity power factor. Because of this type of circuits comes to pure resistive. If the pure resistive circuit having some unity power factor, simply the angle is 0, the phase angle is 0. Now coming to the graphic representation of series resonance. This graphic representation is mainly drawn between impedance versus resonance frequency, that is FR versus Z. In our Z, we have total 3 parameters are there: resistor, inductive reactance as well as capacitive reactance. If you are taking the frequency formulas, if you are taking the resonance frequency formulas, then we can get simply I am taking R. R is an independent of frequency because of there is no relation between resistor as well as frequency. That is the first point. Now coming to XL. If you are writing XL equal to omega L, simply I am writing 2 into pi into f into L. The f and XL both are linear. From this explanation, simply I am writing the summary point of this total value, that XL is proportional to f. Similarly, I am getting the next condition, XC is inversely proportional to frequency from this explanation. Now R is the independent of frequency, that's the first point, and XL is proportional to the frequency, second point. The XC, inductive capacitive reactance, is the inversely proportional to the frequency. These are the 3 points. From these 3 points, we need to draw the total graphic representation of series resonance. The x-axis is taking as frequency or angular frequency, and y-axis comes to resistor XL and XC and impedance. Okay, actually in y-axis we have a response also, the system response. I am taking the another graph for this one. Why? Because if you are drawn in this only, that is a very complex graphic representation to represent the response of the system. Okay, y-axis is nothing but what? Y-axis is nothing but what? It is a combination of resistor XL and XC and Z, and y-axis is called angular frequency as well as normal frequency. Sir, if you are drawing between resistor as well as frequency, this is not in the resistance is not depends upon frequency. Simply I am writing the constant line. This is called resistive line. If you are taking the these two representation, that is XL and F, both are proportional, that is both are linear. Simply I am taking this curve. This is a linear curve. This is also represented with XL. And coming to XC and frequency, these two are inversely proportional. If you are taking inversely proportional, the total curve like this. This is a XC curve. This is a XL curve. This comes to resistive curve. Okay, the combination of these three, I am getting some resultant curve. That resultant curve is nothing but Z. This is a parabola curve. The parabola curve is nothing but that is a resultant of all these things, R and XL and XC. At this point, the XL and XC both are equal. Simply that point is called as a resonance point. And before this resonance point, which is a higher value compared to XL and XC? The XC is higher value. Simply this type of circuit is called as capacitive circuit. Before resonance, the total circuit comes to capacitive circuit. After completion of resonance, the XL is higher value compared to XC. Now this type of circuit is called as inductive circuit. That's why I am represented with XC is greater than XL before the resonance. After resonance, XL is higher value compared to XC after a resonance. This type of circuit is called inductive circuit, and this comes to capacitive circuit. At the resonance, this point is called resistive circuit. This series resonance, RLC resonance, is also called as voltage magnification circuit. Okay, the series RLC resonance is also called as voltage magnification circuit, and is also called as acceptor circuit. Acceptor circuit. Now coming to the graphical representation of the series RLC resonance, the current versus frequency. If you are taking the parabola curve from the above graph, this is a parabola graph from the resultant of the above graph. This Z is inversely proportional to what? Current. The Z is inversely proportional to current. Why? Because I is the inversely proportional to Z. Simply I am taking the inverse parabola curve for current. Inverse parabola curve for current. Already I explained the series RLC resonance is also called as voltage magnification circuit because of the voltage across the inductor and capacitor are Q times of supply voltage at resonance. At resonance, the voltage inductor voltage as well as capacitor voltage is more than the supply voltage at resonance, simply I am writing VL equal to Q times of V, and VC equal to Q times of V. These are the two important formulas to find the quality factor of the resonance circuit. Now Q equal to, I am taking VL by V, VL equal to I into XL, just cancel these two terms, then we can get XL by R. We substitute that XL value, XL equal to omega L into R, then we can get the quality factor equal to omega L by R in terms of resistor as well as inductor. If you are taking the VC equal to Q into V formula, then we can get Q equal to 1 by omega C here is the quality factor formula in terms of resistor as well as capacitor. That quality factor is also called as figure of merit and magnification factor. Magnification factor as well as figure of merit and quality factor, all are same. Now if you are taking omega R equal to 1 by root LC from the previous explanation, then substitute that omega R equal to 1 by root LC in this formula, then we can get 1 by R under root of root L by C. Now what is the units of quality factor? No units. Coming to the relation between bandwidth, resonance frequency and quality factor. These are very important formula for any competitive exams. This formula is very useful to you. Now first of all, what is bandwidth first? Bandwidth is nothing but our gain of the circuit is reduced to 1 by root 2 times of the maximum value is known as bandwidth. Simply I am writing this, that is total is the maximum value, is a total gain of the resonance, series resonance, that is IM. That IM is reduced to 1 by root 3 times, then we can get two frequencies, that is omega 1 and omega 2 frequency. If the line is touches the total inverse parabolic curve at omega 1 and omega 2. If you are taking omega 1 is a lower cutoff frequency and this comes to higher cutoff frequency, now the distance between these two frequencies is called as bandwidth. Okay, the distance between higher cutoff frequency minus lower cutoff frequency, simply that is called bandwidth. Or we have another definition, the total maximum value, the maximum value is reduced to 1 by root 2 times or 0.707 times of maximum value, that is also called bandwidth. Now what is the bandwidth formula? Upper cutoff frequency minus lower cutoff frequency. What is the units of bandwidth? The radian per second. And coming to relation between bandwidth, resonance frequency and quality factor, that is equal to FR by Q equal to bandwidth. Bandwidth is nothing but resonance frequency by quality factor. The units are Hz. Thank you.